Okay, welcome everyone to this webinar. Yes, just as an introduction, my name is Catherine Akinyodira. I work as an Earth Observation Project Manager at KappaZeta, and today I'll be taking you through this webinar on AI-based tillage detection for improved agricultural and climate policies, which is a project that we have been undertaking and is funded by ESA. Just a bit of housekeeping. We'll have a Q&A session at the end of the presentation. In case you have any questions, we can answer questions at that juncture. But if you have a burning question and you cannot wait till the end of the presentation, you can unmute and ask the question or write directly in the chat box. Yeah, so we'll get started, and just a bit of the content of the webinar, what to expect. So we'll have a bit of an introduction, and then we'll take you through the workflow of the procedure that we followed in order to obtain the results for the models that we'll be showcasing the results for. And then we will now show you the results for the conventional tillage detection model and conservation tillage detection model. And then we'll have the last segment, which will be on Q&A. And there you can ask all the questions that you have. So I'll start off with a bit of the introduction, and just to answer the question why tillage detection is important. And in the context of this project, the main aim was to support the work that is being undertaken for the Common Agriculture Policy, whereby tillage is one of the use cases listed for subsidy checks under the Common Agriculture Policy. And in this, it ensures that farmers who are undertaking farming practices that are environmentally friendly would get remunerated for that. And another point is that there's a realization that conventional tillage has got a lot of negative environmental impact, in that since conventional tillage tends to be undertaken in a manner that tends to be very intrusive to the soil, this leads to the release of greenhouse gases such as carbon and carbon dioxide and nitrogen. And this is something that we are trying to mitigate in terms of environmental policies. And farmers are encouraged to now start undertaking farming practices that will encourage carbon sequestration, which is conservation tillage. And I'll be able to expound on this later on in the presentation. And so that brings us to the most important aspect of this project, which is the need to distinguish and detect the different tillage practices. As I've mentioned, we have conventional and conservation tillage practices. And the main aim of doing this is to try and also support the work that is being undertaken by agricultural paying agencies, carbon emission trading organizations, and agriculture insurance agencies, amongst other organizations that would benefit from the results of this project. I will now move on to talking about the area of interest, which was for this project, we were focusing on the Baltic Sea region, which comprises of 8 countries. That is Sweden, Finland, Estonia, Latvia, Lithuania, Poland, Northern Germany, and Denmark. So the results that we'll be showing you in the third segment will be focused on these 8 countries. And so I'll move on to talk a bit about the types of tillage practices. So for the tillage practices, they fall under 2 major categories. We have conventional tillage and conservation tillage. And how do we tell these 2 types of tillage apart? It's by the crop residue cover that is left behind after maybe harvesting, and for how long it's left on the field. So for conventional tillage, It's categorized as any type of tillage that leaves behind crop residue that is left less than 15% on the soil. And for conservation tillage, it's any type of tillage that leaves behind crop residue cover that is greater than 15%. But these are the major categories. So there are other types of tillage practices that you are maybe conversant with that fall under the different categories. And for conventional tillage, as an example, you have plowing and harrowing, which are the most common conventional tillage practices. And then for conservation tillage, you have got two broad categories that fall still under this major category. So that's reduced tillage, which is categorized as any type of tillage that leaves behind crop residue that ranges between 15 to 30%. And then there's zero tillage, which is categorized as any type of tillage that leaves behind crop residue that is greater than 30%. Zero tillage is also famously known as direct seeding. You will hear it being referred to as direct seeding, but basically it's zero tillage, meaning after harvesting, the farmer doesn't undertake any type of manipulation to the soil. They just sow directly into the soil without even manipulating the soil in any way. So yeah, this is briefly the introduction, and then now we'll move to the procedure that was followed in order for us to obtain the results that we'll be showcasing. So for the satellite data that was used in this project, we used Sentinel-1, Sentinel-2, Landsat 8, and 9. And from Sentinel-1, we made use of backscatter and coherence information. And from Sentinel-2 and Landsat, we derived indices that would help us to identify the different types of tillage practices. So after that, we did some data processing, and then we derived the satellite time series, which required some time series labeling, which would end up being which would act as input for the model. But for the time series to be labeled, we needed tillage ground truth data. As you can see here, we have this that is coming into us labeling the time series. So it's the tillage ground truth data. And this tillage ground truth data was obtained from farmers and the paying agencies who are within the Baltic Sea region countries. And then we found out that this data was not enough for us to train our models. So we opted to also supplement the data by using data that was obtained using high resolution imagery from Google Earth and also orthophotos. So after that, with that, that served as input into our tillage detection model, which was trained and validated, and we ended up with a tillage detection probability as a result. And for this, you can see that there's this red line, which indicates how confident the model is in that there is a tillage event that took place here, either conservation or conventional. But in this case, it is conservation tillage, meaning that the model was able to detect some crop residue on the parcel. Yeah, so this is briefly the procedure. So I will take you through a bit of the results that we were able to derive from this. And so we'll start with the 6-day coherence model. So as of now, since we don't have the Sentinel-1B, we only have 1A present. Currently, the data that we would use would be 12-day coherence, but we used historical data. Then we were able to derive the 6-day coherence for that when we had Sentinel-1B and 1A. So we'll start talking about the conventional tillage detection model and the results that we obtained under this model. So in this case, we tried generating a single model for the whole of the Baltic Sea region, but then the performance of the model wasn't really good. And so we tried to split the model, the countries into two regions. So we had the Nordic region model, and then we had another model for the Baltic Sea countries and Northern Germany and Poland as one. From this table, you can see how the model performed. From the Nordic region model, you can see that the performance in Sweden was actually the best amongst the two other countries, which is Finland and Denmark, but the model didn't perform really well in Finland as indicated by the F1 score. The other model was the Baltic Sea region model, which comprised of Estonia, Latvia, Lithuania, Northern Germany, and Poland. So for this, Estonia performed really well, but you can see that the model performance in Poland was a bit low, but still a very good result. So this is for the 6-day coherence. I will move on to the 12-day coherence. For this, the model performed better than what we had in the 6-day coherence. And the reason behind this is the fact that we had more ground truth data for training the model for the 12-day coherence conventional tillage detection model. And in this case, the situation was a bit different, in that it's different from the 6-day coherence, in that in the 6-day coherence, one general model for the whole of the Baltic Sea region did not really work for us. But when we tried to develop the model for 12-day coherence, one single model for the whole of the Baltic Sea region, it had a good outcome. So we maintained this as a single model for the whole of the Baltic Sea region. So from this, as you can see, still the performance in Estonia was really good. And the performance in Finland was a bit low, but still 80%, an F1 score of 80% is still considered fair in terms of, yeah. And so I'll show you an example of tillage detection, a detection of a tillage event that happened in Sweden in 2021. So as you can see here, the model shows with a very high probability that tillage did take place at this point, and that was indeed true. As you can even see from the image, there is like this smooth texture on the soil, and you can see it very clearly that something really did take place. And not only to take that from the Sentinel-2 perspective, but also if you look at the coherence, there was a drop in coherence, which indicates that there was actually something that happened, which is an event. So this was indeed a tillage event that took place. This was for the 6-day coherence model. We'll now move forward to the conservation tillage detection model. For the conservation tillage detection model, this was a bit different. The approach to developing this model was a bit different, since for conservation tillage, we are more concerned about the detection of presence of crop residue. So the type of crop, which is also related to the type of crop residue that is left behind, is very important. That's why we limited the type of crops to only 5 major crops that are grown in Europe, and that is maize, wheat, oat, barley, and rapeseed, just to be able to test if the model would indeed be able to detect conservation tillage. And for this, we also developed a single model, which was a single model for the whole of the Baltic Sea region. And the performance of the model in this case, as compared to what we had in the conventional tillage model, is quite low as you compare to what we had like in conventional tillage model. We had like 90, above 90%, but here we had 86. But this is fair because it's noted that detecting conservation tillage is quite a challenge. And so for us, this was a result that was good enough. So if we direct your attention to the results table, you would see that from the results, the model performed really well in Sweden as compared to the other countries. And you can see that I have these two rows highlighted in yellow. That is Northern Germany and Poland. And that is because we think the model was a bit biased in these regions because we didn't have enough data for this particular region. You can see, especially in Poland, the model didn't perform really well. The F1 scores like around 60.9. If you compare that with Sweden, which was like 94.1, it's quite low. And so we come to the next section, which is conservation tillage detection model for the 12-day coherence. And if you compare the performance of, in this case, for the 6-day and the 12-day coherence, the performance was a bit low, and that is expected because now we are dealing with 12-day coherence, and this is 6-day coherence. And from this, we found out that still you would see that the performance of the model in Sweden was still good, but then in Northern Germany and Poland was a bit low. But from a country, when you look at the general performance of the model, it's low. But when you look at the performance of the model in each country, it's better in some country and worse in some country, as you could compare it to the 6-day coherence. If I could just go back. So I would focus your attention to Estonia, for example. In 6-day coherence, we had an F1 score of 83.2. But if you see that in 12-day coherence, the F1 score dropped to 74.2. But if you focus on a different country like Latvia, the F1 score was 89.6 for the 6-day coherence, but then for the 12-day coherence, it was 88.3. Now I'll show you an example of a detection that of a conservation tillage detection that took place in Denmark in 2021. And in this instance, you can see for this parcel, there was a harvesting event that took place at this point, and the model correctly identified the presence of crop residue until this point. At this point, you can see that there's a drop in coherence, which means that there was something that happened, but we weren't able to establish in detail what really happened because we can see that there's a missing Sentinel-2 data point. So we weren't able to do that. But generally for this model, it performs well to a particular extent. But we found out that if we don't have data that represent how crop residue cover would look at a particular instance, the model would ideally miss that event. I will just take you back to this point. And this is also one of an instance whereby the crop residue cover was detected in Lithuania. And as you can see, the crop residue was detected for a while, and then the model thought that there was no crop residue, and then the detection happened again after a while. But in total, the crop residue was on the field for approximately 70 days. But the model stopped here because as we investigated this point, and we saw that there was an event whereby it had rained and the crop residue at this point was wet. And since the ground truth data did not capture this type of scenario, the model thought that this was not actually a crop residue event. So crop residue wasn't present on the surface of the parcel. So those are some of the shortcomings that we currently have with the model. But ideally, our main objective was to try and show that conservation tillage detection is actually possible, and we were able to actually do that. I think that brings us to the end of the results section. And now we move to the Q&A. And I would like to maybe get some questions from the audience. Someone has a question based on what I've just presented, or maybe something was not clear. This is now the chance to do that. Are there any volunteers?
I have maybe a question. So
Yes.
The main difference in quality of this process data, like on the initial slides, where was this Sweden, Estonia, different countries comparison? The main difference why the precision is higher is because the amount of data available was bigger, or is there anything else?
No, for conservation tillage, that wouldn't be the explanation, because we ensured that the number of ground truth data for the countries were equal. So it was like 200, yeah, equal, yeah. Does that answer your question?
Yeah, thank you.
Any other question?
Maybe I have one question until
Yes.
there's radio silence. Did you also test out either of these models on a single country, or did you test out like training it on single countries, training data, and also running the model and testing the results? Or did you only do it purely in the North Sea region, like a generic model?
Yeah, that's a very good question. Thank you so much. For this case, we just developed a generic model, but we believe that if the model was customized for a single country, and we have enough ground truth data in that particular country, it would be able to yield better performance as what we are seeing right now.
Very good. Thank you.
You're welcome. Any other person? Any other question?
Follow up to that then. What's the inter-country variance between the model performance, or why does the model perform differently in different countries? Are the tillage practices different? The crop signatures different? What exactly is the challenge in generalizing the model?
Yeah, that's a very good question. One thing that also led us to having to model for the conventional tillage detection model 6-day coherence is that we found out that the NDVI value in the different regions, like the type of soil and the type of crop also, it's very different for the different countries. So when we try to generalize the model, the errors are also distributed in the model. So that also becomes an issue for us. Does that answer your question?
Yeah, it makes it a bit clear. So the NDVI signatures for the crops are basically different.
Yes.
And that affects the model sensitivity. How does the model behave then? Does it give like wrong, like false positives, or it just fails to detect these events? Like what's the...
Yeah, like for the model, you find that there are a lot of false positive most of the time.
Okay.
Yes.
Okay. Let me ask some more questions there. Thank you.
Okay, thank you. Any other question?
I have a question. I'm not sure, maybe it went over my head, but
okay.
How do you are going to deal with this rain example that you gave? Like, are you trying to implement the rain detection into a model, or just yeah? Did you got my question?
Yes. Yeah. I've understood your question. That is based on this example that I went back to, this one, whereby we had like wet crop residue. Is that right?
Yeah.
So the problem is that we weren't able to capture the whole event, but because we lacked a lot of ground truth data that we received from like farmers, we didn't have adequate data to represent this. But it would be a good idea or to have this coming from the farmers. It would actually give us a very good idea of to what extent do we extend the labels of them in order to train the model. So for now, we have the limitation whereby we had to use high resolution imagery. And for that, we have only one instance, which does not really represent everything that is going to happen throughout the season. Does that answer your question?
Yeah, thank you. It was really good.
Okay. You're welcome. Okay, any other question?
Hello, do you hear me?
Hand raised.
Yes, we can hear you.
I have a question. If you use any geotagged photos as a ground truth evidence, or just imagery from PHR imagery and Sentinel?
If I get your question correctly, you're asking if we used any geotagged, like auto photos?
No. If you use geotagged photos from farmers or from the ping agencies to verify the events.
No, actually that was not done. But what we do whenever we receive data from farmers and the paying agencies, we try to check the events against the time series. So for example, in this case, maybe the farmer reported that the tillage, the conventional tillage event took place at this point. But we ideally know that when there's a drop in coherence, and also by checking the Sentinel-2 image, we will be able to see clearly what is happening on the farm at a particular time. So we are able to adjust the labels, but we didn't use any geotagged photos from farmers. Yes. Does that answer your question?
Thank you. That's clear.
Yeah. Any other question? Okay. Since there's a long silence, I would like us to maybe help in participating a small test. It's not a test, it's like a small task whereby if you could just scan this QR code and help us to answer 2 questions that are in that link. And then that would really help us. And if you have any questions, we are still here. Kindly just ask and we'll be able to clarify.
I think there was a hand up.
Okay. Go ahead and ask your question.
Or was it by mistake?
Probably.
I think it was answered already.
Okay.
Okay, thank you. I'm waiting for more questions. Yeah, and I can see the votes are coming in. Okay. If you're not you're not sure about the the question to ask. It's okay. Any question is welcomed. And in case you're shy to speak, you can just write in the chat.
Catherine?
Yes.
So I have one question. That knowledge that you gained now, okay, that was you and Tanya, as I understand,
Yes.
for this tillage. And so how will we start using that knowledge that you got in Estonian and Danish and probably in the future some other countries, this AMSs? Thank you.
I think, yeah, that's a very good question. I think the main thing that we got from this project is that only using NDVI for tillage detection is not satisfactory. Using other indices that are capable of detecting the presence of crop residue is the way to go, like NDTI and NDI7. So I think incorporating that will help us to fine-tune the models for Estonia and Denmark as well. Does that answer your question?
Thank you.
Okay. Thank you.
Sorry, since we're still here, then what time frames did you consider for this detection? I guess the main spring summer season, so from April to end of October?
From March to end of November.
Okay.
Yeah.
And this is typically the time frame for time seeds for tillage events in this part of Europe, I guess. I'm just trying to understand how the model performs in times where the Sentinel-2 data is quite sparse, and how much the Sentinel-1 improve the accuracy of or the confidence of the probabilities in certain cases. Because like you mentioned, the comparison between 6-day and 12-day.
Yeah.
So what has been the impact of Sentinel-1 and on the model performance?
Oh yeah, for example, like for us, like in terms of the 6-day and the 12-day coherence didn't have a big impact on the model as compared to I think I wouldn't want to answer this question. I think Tanya would be the one who's best placed to answer this question clearly.
Okay.
Yeah. Do you have any other question?
I have another one, another question. If I understand correctly, so far, none of the involved countries have adopted this model in the operational level. Am I wrong?
Yes, you're right. None of them have adopted the model, but the conventional tillage model, we have a model for detecting plowing events for Denmark and Estonia. Am I right, Indra?
Yes, so we have dedicated models for the two countries, but in a way, the conventional tillage models, which were developed as part of the tillage project, are different. So it's not exactly the same models.
Yeah, thank you, Indra. Yes, does that answer your question?
Yes, thank you.
Okay.
I guess a general question to everyone who's very familiar with the topic as well, that is there a clear market use case for conventional tillage, except for cases when the government require you to develop these models? Is there any market at all for this? I don't know, from farming agencies, or what other use case could there be for this? If anyone has some ideas, just curious.
So that question is directed to the audience. Okay.
Yeah, anyone. Yeah.
Thank you. Yeah, anyone who has any idea would kindly answer the question, please. Okay. So
Catherine, Ted should have some ideas at least. Is Ted somewhere here?
Yes, I am.
He is here.
I had difficulties to see the right window. At the moment, I suggest that maybe we can discuss it not here at this given moment, but
Okay. Any more questions before we end the webinar? I wouldn't want to close anyone out in case you have any question, any type of question. It's welcomed. Okay, and yeah, thank you so much for also answering the poll on how, if you think that the model will be of interest to you based on your various use cases. And I can see quite a number of people have said yes to that, and many people would be interested to test out how the model performs in their area of interest for both. So both conventional and conservation tillage would be of interest to them. Okay, yeah, thank you so much for the ones who have managed to answer the poll. And thank you so much for making the time to attend this webinar and for asking questions. Thank you so much. And would like to wish you a wonderful weekend. Yeah, thank you. Have a good day.